Hello, everyone. Welcome to Lecture 7. What we're going to do today is we're going to go backwards a bit and kind of review and take a breath and see what we're up to, okay? I posted on Blackboard a worksheet, so we'll go over those problems that I put on Blackboard, scientific notation, unit conversion, some kinematics, and we'll see how that goes. And then we'll proceed with the next chapter, chapter 3, and get into energy, but not in this lecture. All right, let's take a look. Scientific notation, okay? Powers of 10. Remember our rule? When you multiply, you add exponents, and when you divide, you subtract exponents. So let's go over this quick. First one was 10 to the third times 10 to the 8, 3 plus 8, 10 to the plus 11. Next one, 10 to the negative 11 times 10 to the 16th. We have negative 11 plus 16 is plus 5. Make sure I do my math right, okay? 10 to the negative 17 divided by 10 to the minus 6 sixth power, right? We have to subtract exponents. So we have negative 17 minus a negative 6 becomes plus 6. So negative 17 plus 6 is 10 to the minus 11th. Right? 10 to the 15th divided by 10 to the minus 9. Again, we subtract the negative. The negative 9 becomes a plus. We have 10 to the plus 24. And finally, 10 to the minus 23rd divided by 10 to the minus 18. It's minus 23. The negative of minus 18 becomes plus 18, so I believe the answer is 10 to the minus 5th. Okay, check your answers, feel good, tap yourself on the back. We got something right. All right, let's go on. Let's talk about the unit conversions. This is probably the most difficult part for everyone. What I want you to do, if you can, is to try to do as many of these in your head as quickly as possible. Okay, remember we're training for the TEAS exam, the nursing exam, and time is your biggest enemy, and we don't want to waste time on a calculator. Okay, we can do these things in our head, and we want to also connect those neurons, get to thinking. All right, so recall this number line that I gave you the last time or one of the other earlier times. Again, if you get the answer doing it your way, then and every time it's the correct answer, then just do it your way. Doesn't matter. There's no one way to do it. Just trying to give you a way that perhaps is easier. So let's just review this line. 0 represents 10 to the 0, which would be 1. Plus 3 is kilo, thousand. Minus 2, centi. Minus 3, milli. Minus 6, micro, millionth. Minus 9, nano, billionth. Okay? So let's do some linear conversions. A micrometer, 2 kilometers. How many kilometers make 1 micrometer? Once again, our silly rule is when this side is bigger, the exponent is negative. Remember, bigger, smaller. Bigger is negative. Okay? Now, kilo is plus 3. Micro is minus 6. If we count the number of steps, there's 9 steps. So this should be 10 to the minus 9. Okay? So you check my results. All right? Next one, centimeters, nanometers. Nanometers are smaller than centimeters. So smaller is positive. We put a plus there. Nano is what? 10 to the minus 9. Centi is minus 2. So how many steps? 7. So this would be 10 to the plus 7. Not that bad, okay? Again, pat yourself on the back if you're getting these correct. Now, we go to 2-dimension. Remember, an area is 2-dimension. Millimeter by millimeter, or centimeter by centimeter, or meter by meter. That's an area, okay? Now we want millimeters squared and kilometers squared. This, we're just going to talk about. I'm not going to write it out or anything like that. But let's look. Kilo is bigger than milli. So we're going to have a 10 to the minus power, okay? Kilo and milli. Kilo is plus 3. Milli is minus 3. So 1 millimeter is 10 to the minus 6. There's 6 steps. 10 to the minus 6 kilometer. 1 millimeter is 10 to the minus 6th kilometer. So 1 millimeter squared is what? It's a millimeter times a millimeter. So it's 10 to the minus 6 times 10 to the minus 6. So the answer, I guess, should be 10 to the minus 12. Okay? Kilometer cubed, millimeter cubed. Cube, remember, is a volume, a length times a width times a height. All right? Millimeter is smaller than kilometer. Remember, smaller is positive. Okay? Where's millimeter? Well, again, millimeter is minus 3, kilometer is plus 3. So 1 kilometer is 10 to the plus 6, right? 3 and 3 is 6 steps. So 1 kilometer is 10 to the 6th millimeters. So 1 kilometer cubed is 1 kilometer times 1 kilometer times 1 kilometer. So we have 10 to the 6th millimeter times 10 to the 6th millimeter times 10 to the 6th millimeter. So 10 to the 6 times 10 to the 6 times 10 to the 6. We add the exponents. 10 to the 18th. Look at how smart we are. Isn't this amazing? Fantastic. All right, now I throw a curve in, don't I? Oh, so tricky. All right, let's ignore this 10 to the minus 12 for now. Okay? Let's do millimeters and nanometers first. Millimeter, nanometer. Remember, nanometer is smaller. Smaller is positive. Okay? So I'll say positive for now. So nanometer, millimeter. Nano is 9. Millimeter is minus 3. So the difference is 6. Remember, this is smaller. So this is smaller, so it's 10 to the plus 6. So millimeter cubed is 10 to the 6th nanometers times 10 to the 6th nanometers times 10 to the 6th nanometers. So 1 millimeter cubed is 10 to the 18th nanometers cubed. 10 to the 18th. Now, multiply 10 to the 18 times 10 to the minus 12. Well, 10 to the 18 times 10 to the minus 12. 18 minus 12 should be 10 to the 6th. Okay, 10 to the 6th. So the answer should be 10 to the 6th. All right. Again, let's play the same game. Micrometers, bigger or smaller than centimeters? Micrometer is smaller. Smaller is positive. Remember, smaller is positive. Positive. So micrometer is 6, centimeter is 2. So 1 centimeter is 10 to the 4th. 1 centimeter is 10 to the 4th micrometers. 1 centimeter squared then is 10 to the 4 times 10 to the 4 is 10 to the 8th micrometers squared. So now we take 10 to the 8, multiply it by 10 to the 5, and I guess we get 10 to the plus 13. Okay? All right, our final conversion. What are we going? We're going kilometers, micrometers. This is bigger, so the exponent, remember when it's bigger, it's negative. We go between micrometer and kilometer. Micrometer is here, kilometer is here. So 1 micrometer, there's 9 steps, right, is 10 to the minus 9 kilometer. When we cube that, we get 10 to the minus 9 times 10 to the minus 9 times 10 to the minus 9 is 10 to the minus 27. In other words, 1 micrometer cubed is 10 to the minus 27 kilometers cubed. 10 to the minus 27. That's 1 micrometer cubed. When we multiply 10 to the minus 27 by 10 to the minus 11, 10 to the minus 11 times 10 to the minus 27 is 10 to the minus 38. Okay? All right, let's go on to some kinematics, shall we? The first problem we're going to do has to do with acceleration and deceleration. Remember, if you're given an initial speed and the object accelerates, then the answer must be greater than the initial speed, acceleration. If you're given an initial speed and the object decelerates, then clearly the final velocity or speed must be less than the initial speed. Acceleration, deceleration. Okay? The formula we wrote V, I'm going to write final, equals V, I'm going to write initial, or V0, plus or minus the acceleration times the time. Now, I understand there's a lot of confusion by many students. They want to take the acceleration to be g, the acceleration due to gravity. Remember, the acceleration due to gravity only comes into play when we're falling or moving upwards vertically. Gravity only acts this way, up and down, does not operate this way, okay? So when we have a car or a truck or a train, the acceleration can be anything. It could be 10 meters per second squared. It could be 2.873 meters per second squared. It can be anything we want, okay? Now, in the example I gave, a car traveling at an initial speed of 35 meters per second, then accelerates at a rate of 4 meters per second squared for 5 seconds. So, accelerates, we're going to take the plus sign. So V final, what was our initial speed? It was 35 meters per second. We're going to take plus, what's the acceleration? I believe I said the acceleration was 4 meters per second squared, and the time was 5 seconds. Okay, now look at the units, meters per second. V final had better be meters per second. Here we have meters per second squared times seconds. 1 power of seconds will go out, and we'll be left with meters per second. So we have V final is 35 meters per second plus 20 meters per second. And so our final speed is 55 meters per second. Okay? The second part of the problem says, what if you decelerate? Decelerate means you go slower. Okay? So, what do we do with this equation? What do we do? Well, we take the negative sign. Decelerate, we take the negative sign. Decelerates, we're going to take V final is V initial minus AT. And so I'm just going to plug in the numbers we had before. 35 meters per second minus 4 meters per second squared. Oops. Okay. And then 5 seconds. So now we take 35 and we subtract 20, and we get 15 meters per second, V final. Okay? So if you accelerate, the speed is greater. If you decelerate, the speed is less. That's it. It's as hard as it's going to get for us. All right? On a multiple choice exam, again, if you see a particle accelerates and there's 2 choices that are less than the initial speed, throw them out. Cannot be right. By the same token, if you get a multiple choice problem and it says that the object decelerates, then the final speed must be less than the initial speed. No tricks. Common sense. Think. All right, next thing we did in kinematics is we took objects and we dropped them and threw them up and everything. Before we do that, let's review once more what G is. Remember, G is technically, it's really 9.8 meters per second squared. For the problems we're doing, we're going to approximate this to give, this is good enough for us, 10 meters per second squared. What is G? G is not gravity. It's not gravity. It's the acceleration due to gravity on Earth. All right? And let's review again what this means, what 10 meters per second squared means. What it means is, ignoring air resistance, if I take an object and I let go, or I throw it, when an object falls, every second its speed increases by 10 meters per second every second. So if I drop an object, in 4 seconds, it's moving at 40 meters per second. In 11 seconds, it's moving at 110 meters per second. Every second it falls, the speed increases by 10 meters per second every second. By the same token, if I throw an object straight upwards, what's happening? Well, the acceleration due to gravity is this way, so the object is decelerating, and so its speed decreases by 10 meters per second every second. Okay, so the next problem I gave was consider an object that is thrown straight downward from the top of a building at an initial speed of 40 meters per second. Okay? The question is, how far is the object falling after 2 seconds, 4 seconds, 6 seconds? All right, how far? Well, if you remember our equation, distance, we could call that delta x, we could be very fancy if we want, is equal to v0t plus 1/2 at squared. V0 was initial speed, right? This is 0 because we're dropping an object. Right? There's no initial speed. And when we drop something, the acceleration now is equal to g. So our formula for d, or delta x, or delta y, whatever you want, is 1/2 gt squared. And what are we taking g to be? G is going to be taken as 10. So let's see. What's the first one? So I want to know, how far does an object fall after 2 seconds? Let's do this together, okay? What is t? T is 2. 2 squared is what? 4 times 10 is 40, correct? Half of 40 is what? 20. So d equals 1/2. I'm going to put 10 meters per second squared times 2 seconds squared. So we have 1/2 10 meters per second squared times 4 seconds squared. So we get 4 times 10 is 40, divided by 2 is 20 meters. Fantastic. Next one. 4 seconds. How far does it fall? Well, d is, let's do it together in our heads. Let's go 4. What's 4 squared? 16. Times 10? 160. Divided by 2? 80 meters. Again, 4 squared is 16. Times 10 is 160. Divided by 2? 80. Next one. 5 seconds. Let's go. In your head, let's go. 5 seconds. 5 squared is 25 times 10, 250. Divided by 2, 125 meters. Oh, isn't this hard? Next one. What do we have? Oh, I did 4 seconds, 5 seconds, 6 seconds. Let's do 6 seconds. D equals, here we go. So easy. What's 6 squared? 36 times 10, 360. Divided by 2 is what? 180? And so forth. Very, very simple. Take t squared, multiply by 10, divided by 2. Okay? The next problem we did was how long? Okay? How long? So now we want the time. We want the time. So in this equation, we have d. We have a half, we have g, we need to solve for t. So we know the distance, we know a half, we know g, we need to solve for t. And that's where we got the square root. Okay? Remember square roots? Once again, we can approximate. It's good enough for everything we're doing. So if I take the square root of 49, we all agree it's 7. Fantastic. What the heck is the square root of 64? Well, that's 8. Great. Now, what if I said, what is the square root of 57? Well, we don't need a calculator. You know what? It's between 7 and 8. So it's going to be 7 point something. Okay? That's good enough. On a multiple choice exam, the answer won't be 7.24, 7.18, 7.62. 7 point something is all you need. So approximating the square root, you can get the answer right away. Okay. So we have that t, when we solve for t, we did in an earlier lecture, 2d over g, the square root. Remember, we're taking g to be 10. Okay? So this is problem number 6. So we want to know the time after 20 meters. Let's do it together. Watch. So this is what we're using for D, right? So what's 2 times 20? 2 times 20 is 40. Divided by 10 is 4. Square root of 4, 2 seconds. Next one, 200 meters. Okay? So the time is, let's do it together. 2 times 200 is 400. Divided by 10 is 40. So the time is the square root of 40. What is that? I don't know, 6 point something. I don't care. Next one, 350 meters. What do we have? Well, 2 times 350 is what? 700. Divided by 10 is 70. So t is equal to the square root of 70. What is the square root of 70? Well, 8 times 8 is 64. 9 times 9 is 81. 8 point something. See? Not that bad. 450 meters. I'll go up here. $450 meters. What's the time? D is 450 meters. 2 times 450 is 900. Divided by 10 is 90. So the time is the square root of 90. What is the square root of 90? I don't know, 9 point whatever. Right? 9 times 9 is 81. 10 times 10 is 100. 150 meters. This gets old very quick. D is 150. 2 times 150 is 300. Divided by 10 is 30. Square root of 30. What's the square root of 30? I don't know. It's about equal to 5 point whatever. It's good. And finally, 500 meters. What do we get? Well, D is 500 meters. 2 times 500 is 1,000. Divided by 10 is 100. Square root of 100, we get 10 seconds. Okay? So if you can do these, and if you can learn to do them in your head, you got it made. All right, in the next lecture, what we'll do is we're going to proceed with the next chapter, which deals with energy and work and all that good stuff. See you next time. Be well.